Hi everyone, 9.6 today. We're going to learn about solving for right triangles. Yes, I said right triangles. And to do that, we're going to have to find missing angles. First of all, we have these inverse trig functions, and the inverse trig functions are used to find or solve. So we're going to use this to find a missing angle. So inverse tangent is just going to be this little tangent with the little -1 looking thing, but that is not an exponent. Inverse sine looks like sine with the little -1, so that's red, the inverse sine. And then we have inverse cosine. Those are in your calculator. You have to press the second button, and then you press the regular sine, cosine, or tangent button. And these are still relating to our normal ratio. So tangent is going to be opposite over adjacent, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. Okay, that is what this is. And solving a right triangle just means we want to find all three sides and angles in a right triangle. So let's just get into the nitty gritty here. Next page. I'm going to go down to this little extra practice here. The cosine of an angle is 24 over 25. You don't have to have a picture here, but we want to find, it says which of the angles is this? So cosine here means, actually we do need a picture for this question, sorry. Cosine means adjacent over hypotenuse. So my adjacent is the 24. So what's adjacent would be angle F. So here just be angle F is what this represents. And number two, sine is about 0.38. What you would do here is you would actually take these decimal versions of these um, radicals, and you need to figure out which one. Is it the square root of 2 divided by 2 square roots of 3, or is it the square root of 14 divided by 2 square roots of 3, because that would be the ones dividing by the hypotenuse. Whichever one that is, you're going to look at which one shows the opposite would be the correct one. Calculator work, sine of h. Here's what this means. If you want to find the angle that has the sine ratio of 0.2 in the calculator, you take the inverse sine of 0.2. And you are going to put that in the calculator. So you're going to press second, and then the sine button, and then put 0.2, press enter, and we're going to round, it says, to the nearest tenth of a degree, which would be 11.5 degrees. So again, that would be an 11.5 degree angle. I'm not going to do the other ones, but then you would say inverse tangent of 1. For number 5, you would say, what's the inverse cosine of 0.33? And we just write one decimal place. Good? Great. All right, next page. Okay, on this page, we are going to solve for the right triangle. Now, a couple little things here to tell you about. If you ever have two sides out of the three, you can use Pythagorean theorem to find a missing side. If you have two out of the three angles, you can use your triangle sum theorem. Also, when we're solving, just so you know, the opposite an angle, we usually will write with a lowercase letters. So my hypotenuse in number 7 will be represented as little b. Across from A, the side length with the 12 would be little a. And then across from C, which is 6, would be the little c. So when they ask to solve, we're eventually going to want to know what is A, what is B, what is C, and we're also going to want to know what is the measure of angle A, what is the measure of angle B, and what is the measure of angle C. Now, easy parts to do first. Little a is now 12, little c is 6, and B is 90 degrees. Those are our givens. If I know two of my three sides, to find B, I'm going to do this here at the bottom, I can do Pythagorean theorem. B is my hypotenuse, so I can say B squared equals 6 squared plus 12 squared. Now, in my calculator, if I put 6 squared plus 12 squared, I get 180. Take that square root, I'm going to get 13.4 when I round. So that'll be 13.4. So I'm going to put that in here. And I'm actually going to write it in this big one. Now, to find the measures of angles A and C, I don't know any angles except for my 90-degree angle. That means I have to use an inverse trig function. Let's focus on maybe angle A here. Angle A, I have my 12 is my opposite, 6 is my adjacent. Now I'm going to use those because there's no decimals. It'll make it easier. So to find angle A, I can use my tangent. So inverse tangent, opposite, which is 12, divided by adjacent, which is 6, is going to give me angle A. So my calculator, I press second tangent, 12 divided by 6, and I get 63.4. If I know that 63.4 degrees, I can use my triangle sum theorem. So I can take 90 plus 64, 3.4 and subtract that from 180. And I'm going to get that my missing angle is now 26.6 degrees. So that's when we know two of the sides. Now let's go ahead and do a question like, let's skip over to number 10. So again, number 10, I'm going to make spaces for my answers over here. I want to know the measurement of angle X, angle Y, angle Z, and I want to know little x, little y, little z. So my side links. Now here's what I know so far is I know Z is 29 degrees and I know X is 90 degrees. So if I do my triangle sum theorem and subtract those from 180, I get 61 degrees for angle Y. And I might actually write that in my problem. I also know little z, which is across from big Z, is now 18. Again, we have little z, little x, little y. When you don't know two sides of a triangle, we have to use trig functions. Let's focus on the angle that we know. We know 29. So 18 is my opposite here. So I'm going to use an opposite. Let's use maybe sine. I can say sine 29 degrees equals my opposite, which is 18, divided by my hypotenuse, which is my x. So I'm going to swap those. Remember, when the variables in the denominator, swap them. And I'm going to say 18 divided by the sine of 29, round to one decimal place, and I get 37.1. So x is 37.1. Now at this point, I have two options. I can use my 18 and my 37.1 and use Pythagorean theorem to find the value of the side of that's labeled y. Or I can use another trig function. So I'm just going to model this with a trig function, and I'll also show you Pythagorean theorem. If I did a trig function, I would want to use my opposite and now my adjacent. So I could say opposite and adjacent would be tangent. So I could say tangent of 29 degrees equals opposite, which is 18, divided by adjacent, which is y. And now I would take 18 divided by the tangent of 29, and I get 32.5. I'm going to show it to you with Pythagorean theorem really quick. I could have taken my hypotenuse, which is, what is that, 37.1, and squared that. Actually, I don't need parentheses. And set that equal to 18 squared plus y squared. And then 37.1 squared minus 18 squared would give me 1052.41 equals y squared. If I take that square root and round that to the nearest tenth, that gives me 32.4, which is pretty close to that 32.5. So yeah, very close. So that would be solving for a right triangle. I'm going to skip number 11. Anyways, there was your notes for the 9.6. We'll see you either in class or the next video. Have a great day.